Good afternoon, Facebook. I'm Erica Fernandez with CCIC Communications. We are live right now at Seabrook Intermediate School inside Mr. Brock Breedlove's math 8th grade class. So, Mr. Breedlove, thanks so much for doing this today. What are you guys working on today?
So recently, over the past few weeks, we've been doing a lot of geometry concepts. So we started off with volume last unit, and then this unit we're going to be focused on surface area. Specifically today, we're talking about the surface area of cylinders. And this is day 2, so they should have a pretty good understanding of what they're doing today and take the training wheels off and give them a little bit more work on that.
And we are live inside your classroom today, and we've got your students here. What is the goal of today's lesson?
At the end of the day, they should feel really comfortable finding both the lateral and total surface area of cylinders. So they've already done rectangular prisms, they've done triangular prisms, and then today they should feel really comfortable leaving the classroom knowing how to find the surface area of cylinders.
All right, so if you've watched any of our Live in the Classroom segments, then you know that we let the teacher kind of take over, do a little lesson, and then the kids will get to work. So we'll let you take over now.
Perfect. Thank you very much. Okay, also, what I was just talking about, the goal here today is going to be to find the surface area of cylinders using our formula. We've already done this yesterday, so we should feel pretty comfortable doing that. Day 1, I gave you all the answers, so y'all had to work the process to check and find that answer. Today, take off the training wheels, y'all are going to have to find the answer on your own. So before we get into our actual assignment, I wanted to go over a couple things just to refresh your memory from what we talked about yesterday. So the first thing I'm going to do is come over here to this whiteboard. I already got some stuff written up here. We got a cylinder, and we got some fill in the blank stuff, so I need a volunteer to come up here. First thing I want to happen is I want us to label this cylinder, the key components of a cylinder that we need to find the both lateral and total surface area of that. So Braxton, you want to come up here and write what this piece of the cylinder is, and yep, right there, and then that. And you can tell the class too.
So this is the height of the cylinder, and then this is the radius of the cylinder.
That's the radius. Okay, perfect. So those are the two key components we're going to need to find the surface area of the cylinder. And over here, just sort of to recap, remember when we break apart the cylinder, kind of dissect it, and what shapes make up the cylinder. Mia, you want to fill in these blanks here? Which 3 shapes make up a cylinder? And you can let everyone know too. What are you writing here, Mia?
Circle and rectangle.
Just one circle?
2 circles.
2 circles and 1 rectangle, right? We've got 3 shapes, so make sure you make a note of that over there. There you go, right? Because when we break it up, thank you. We had an assignment on this, but when we cut up the cylinder, right, at the end of the day, it is that rectangle and then the 2 bases, those 2 circles, right? So we are asked to find both the area of the circles and the area of that rectangle. And that leads me to probably the toughest one. Who can remember what the actual formula is on top of their head? You got it, Alexa? Okay, let's do it. I want you to put both the first part of the formula and the second part. You could be a little bit more excited, right? This is exciting stuff. Got it? Pi. There you go. So Alexa put up there S equals 2 pi RH plus 2 pi r squared. And I think all y'all know this, but what do R and H represent? Radius and height that Braxton told us about, okay? And the reason why we do that, right? If we were trying to find lateral surface area, that's just going to be this first part. And that first part of the formula represents the rectangle. And then this second part of the formula is going to be the area of the 2 circles, and that's why we put that 2 there, right? Because there's 2 circles, 2 bases. One more thing I want to mention over here on the front board. I need one more volunteer. The one curveball they can throw us instead of giving us the radius, sometimes they give us a cylinder that looks something like this. So can anyone come up here and remind me what we call, again, this, and then what we would call, you got it, Dalton? Come on. I'll walk you through it. So again, let's do both of them here. What's that top one? So again, that's the height up there. It looks a little bit different because it's on its side. But remember, the height of a cylinder is always going to be the distance between the two circles, the distance between the two bases. And then what would that be called? It starts with a D, you said. Can you say it? And I'll walk. Diameter. So it's D-I-A-M-E-T-E-R. And that's the diameter. And what do we do when they give us a diameter? Yep, we divide it by 2, cut it in half to get the radius. So just remember that. Keep that in mind as you're going through your assignment today. We have any questions before I turn you all loose on this and not today. Any questions? We feel good? Okay, so like I said, let's get Weston, Mia, Logan, Hayden. We'll start with that. And I might call a couple more y'all over there. Remember, if you have any questions, quietly ask someone in your group. You want to work with them? Okay, be good. Quietly ask someone in your group. If you still can't figure out the answer, then raise your hand and I'll come help you out. You got it, Justin? You good? So you weren't here yesterday. Do you need any?
I just grabbed some.
But do you need any help, or you think you can figure it out?
No, I have my notes.
Okay, perfect. Good stuff. Okay. Let's get started here. Hey, I'll get y'all real quick. You want to get your notes, or you're good with this? Okay. You don't want a highlighter or where? Is that one gone? Yeah. Give me 1 second. You good, Mia? Okay. So let's get in the habit of making sure. Oh, and real quick, guys, I did want to comment on one thing. On questions 5 and 6, in the parentheses there it says, do not multiply by pi. So what that means is it wants you to take it to that last step before you multiply it by pi to get your answer. And it wants you to just leave it as that. So it'd say like 100 pi or 50 pi. You wouldn't do that last calculation. Okay. So, first one, we're doing lateral surface area, right? So what's the first thing we can do with lateral surface area?
Cross out the right side.
Cross out the right side of that table, right? Because we're doing lateral surface area, so we can just get rid of that whole part. And then let's get in the habit of writing out our formula right here. Y'all got it? By the way, if y'all didn't notice, you have the two formulas right there at the top of your assignment. And then it's as easy as plugging in our R and H. So what do you have for R, Weston? What do you have for your radius? 15, right? Just gives us the radius, so we're good to go on that. And then the height's 32, exactly. And then the first calculation you want to make there is the 15 times the 32. You still getting your highlighters ready? You get 480? Okay. And then we want to take care of the 2, right? So we're going to multiply that 480 by 2. It's right here, Mia, if you needed that. Don't forget your pi.
Is that right?
Here, multiply it by 3. Yeah, but we got to put your units. So what are we putting here? We're putting
Feet squared.
feet squared. Perfect. So remember, you want to use 3.14. No, you didn't do. You forgot the pi. So you got to add that pi there, and then you multiply that number by pi. And how do you label the units? Perfect. Okay. So let's give y'all work ahead if you want to. Let's give me a second to. And then, but make sure you put your units. Okay. So number 2, how is this one different?
It's total.
Total. So we got to include that right side of the table, right? Okay. So, but you're going to use the same process. You're just going to add that piece. What'd you come up with?
30, 14.
Perfect. And don't forget your units and labeling it.
Squared.
Perfect. Okay. You're going to take care of those 2 first, right? Yeah.
That's right.
Mm-hmm. I'm plugging your numbers. You doing all right? Need help? Okay, come over here. Okay. Yeah, get a calculator. Bring your highlighters if you got them. Okay, well, come on. You got it. You know what to put here. Got it all written out here for you. So this is, no, but look, what is this asking for you? Did you read the question?
Oh, the lateral side.
So what do you, yeah, cross that part off. Guys, remember, make sure you understand if they're asking for lateral or total. If they're asking for lateral, we can do what?
Cross to the right.
We can cross off the right side of the chart. We don't have to deal with that second part of the formula. So make sure you understand what they're asking for.
I think I messed up.
Okay, 7.5 squared, is that what you did? And what'd you get? 56. Oh. Thank you.
Okay, we are outside Mr. Breedlove's class now, and I'm with the principal here at Seabrook Intermediate. So we were seeing that Mr. Breedlove pulled some kids aside that were having some trouble, maybe understanding the lesson. And can you explain what that is?
Yes. So, hi, I'm Nicole Hicks. I'm the principal here. So we really have a school focus this year on doing our intervention in real time, intervention really or extension. So if students are not understanding, in the past we might have waited until after like a summative assessment to recap that learning with them. And so what our teachers, especially our math department, is really working on delivering the lesson on day one, doing some kind of post-assessment or some kind of exit ticket and seeing where their class is. And then today, asking, hey, who might need some extra help? They're not quite ready to go about the learning themselves. So he'll pull them up, revisit a couple of things, typically, they try to pull them in light groups, so they're all struggling with the same piece of the learning, and then he'll pull the next group what they might be struggling with something else.
Yeah.
And then, as you saw, there was a student he could tell wasn't working and asked, "Hey, do you need help?" And he was able to come up and get the real-time help he needed.
How have you seen those small groups in the middle of the lesson really help or benefit the kids in their learning?
So it really helps them feel confident in continuing the learning. So what oftentimes can occur is students are sitting there and they don't understand, and they might be apprehensive to raise their hand and ask a question. And when they're quiet, and whether they're working or not, we think, okay, maybe they've mastered this or they understand, and so we continue on through the lesson. Well, all that does is perpetuate the gap. And so this allows the teacher and the students to real-time assess, this is where I am, this is what I might not understand. If I can get a little bit of help, then I'm ready to go to the next unit.
Awesome. Well, we were just live inside Mr. Breedlove's 8th grade math class, and Principal Hicks, thank you so much for having us here, and that'll do it for today's Live in the Classroom. We'll see you again next